This is the last video about LaTeX. Um, in this video I will tell you how to insert images in a LaTeX file and how to extend the capabilities of LaTeX. First of all, we open our project and let's say we want to insert some images. Now, of course, first you have to have the images, and I produced a couple of images using a mathematical software which is called GeoGebra. Maybe you know it, and I saved the images in a directory in my computer. The first thing you have to do is to import the images into the project, because the project, which is this one on the left, shows only the main.txt file, which is the only file that is included in the project. So you click on upload, the button here, and you can drag and drop your files here. So I open the computer, the window on my computer, and then I drag and drop this image, which is called sample1 and is in PNG format, portable network graphics, and then I upload another image which is in JPEG format. Now we have both images loaded, and you remember that a couple of videos ago I told you that we need this package GraphicX, and the package GraphicX does exactly the job of making easy to import images. So we can start, say, a section. Let's say section, say images, and then the command, well, first of all we want the image to be, say, in the middle of the screen, so we want a begin center and center environment so that the image is in the middle of the row, and the command is include graphics, and you see that you already get this. You see there are two items to fill in. The first one in square brackets needs the options. Now the most common option you are going to use is the width of the image, so you might say something like width equals, say, 10 centimeters, and this tells LaTeX to resize the picture so that it occupies exactly 10 centimeters in the page. Remember that LaTeX thinks of a physical page, in this case an A4 paper sheet. And the second, in braces, you have to input the name of the file. So in this case could be sample1, and you see that we get the two options from the editor, because of course the editor knows that sample1 and sample2 are inside, so we go for sample1 now, and so let's see what happens now. The file is just compiling, and then we get the first image. Of course, there was a blank space here in page 2 because the image didn't fit the space, and so of course the image cannot be cut at a certain level, so it's shown here. And then we might have something like second image, and then is enough just to copy and paste the same thing, and instead of sample1.png, let's say we have sample2.jpg, and so we have this second image which is shown here, and this is for say inserting images. The second part of this video is about macros. Some commands are very long to type. For example, to get the symbol that denotes the real numbers set, which is this one, the one here, this big R, you need two things. First of all, you need to load the special fonts, and this is done by going at the beginning in the preamble, in the part that stays before the begin document, and load another package which is AMS fonts. Yes. And secondly, you need to use the capital R font, and the capital R is obtained, say, real numbers math \math BB R. And what you get this way is exactly the same symbol you see here. Now, of course, if every time you need to write the real numbers symbol in the document, maybe this is extremely time consuming, especially when writing about calculus, where you have many functions from R to R and things like that. So the idea is that to create some shortcuts that make the typing of these common sequences of characters easier. So to do so, the process is to define what is called the new command. Now, this is not strictly required, so for now listen just to what I'm saying, and then we see that it's not as difficult as it seems. So first of all, we have a new command, which is, like, say, this one, and the new command, we call it \real. So of course it's for the real. This is the name of the new command we are going to create, and the new command is actually \math BB R. You need a couple of extra braces because of the font, because it changes the font. And now this syntax, this command creates a new command which is called \real, and then instead of writing this, you can just write \real, and you get exactly the same thing as before. But of course, it's obviously easier to type because, well, it's easy to remember that the real number set is \real, and more or less the same way you can define, say, Q for the rational number set, or C for the complex number set, and so on. Now, of course, typing this, say, the two statements at the very beginning is itself time consuming. So what is usually done in this case is to create a file, another file that contains all these definitions and other things, possibly other things. And so this file is called a macro file, and I've actually prepared a macro file that I'm going to upload. So I'm going here to upload this macro file. This macro file is called macros.tech. Now I'm uploading it. So I'm removing use package AMS fonts, and I'm removing the new command. What I'm doing instead is including with \input the macros.tech file. And you see that after the compilation after the compilation, you see that the real numbers here, the symbol is correct here, because actually the macros.tech file is this one, and you see that in line 1 and 2 there are exactly the definitions, the commands that I previously typed into the main.tech file. The advantage is that if you think of having just the main.tech file and having someone that tells you that to get the real number set symbol, you just type \real, is much easier because you know you learn another command which is easy to remember. And by the way, this is just for as an example, in the macros.tag file I created two more commands. One is the one about the absolute value, is called \abs, is here. Well, it's a bit complex, but you don't have to worry about that because you can use it even if you don't understand this. And then you have the another command which is called limfun, which is displays the limit of a function for x that approaches a certain point. So for example, if we go down here and if we go say real numbers and then say that we want an absolute value, and say that we have \abs, and then a couple of braces, and say that we have the absolute value of 1 minus fraction of y over x, and this is enclosed in braces as well. And you see that you get the absolute value sign around 1 minus y over x, which is exactly what you want. And this function was defined, it does not exist in plain LaTeX, but it was defined in the macros. And as another example, we might use the limfun, which takes two arguments here. You see the first one is the function and the second one is the number that x approaches. So if we want to say the limit of f of x as x approaches, for example, 3, we get limit as x approaches 3 of f of x. And you see, of course, this is much easier than typing. The normal syntax would be this one, \lim/limits underscore x to 3 of f of x. That would be the syntax, and of course it's much easier this way. Now, in many cases you are provided with a set of macros, so that you don't have to worry to invent and to study all these macros. And I did the same for problem sets. I have prepared a file that contains many macros that I frequently use, and so you can use as well. And I will make this file available with, say, in the assignments posts.